Center pivot irrigation, also called water heel and circle irrigation, is a method of crop irrigation in which equipment rotates around a pivot and crops are watered with sprinklers. A circular area centered on the pivot is irrigated, often creating a circular pattern in crops when viewed from above. Most center pivots were initially water-powered, and today most are propelled by electric motors. History: center pivot irrigation was invented in 1948 by farmer Frank Zibch, who lived in Strasburg, Colorado. It was recognized as a method to improve water distribution to fields. Overview: center pivot irrigation is a form of overhead sprinkler irrigation consisting of several segments of pipe joined together and supported by trusses, mounted on wheeled towers with sprinklers positioned along its length. The machine moves in a circular pattern and is fed with water from the pivot point at the center of the circle. The outside set of wheels sets the master pace for the rotation. The inner sets of wheels are mounted at hubs between two segments and use angle sensors to detect when the bend at the joint exceeds a certain threshold, and thus, the wheels should be rotated to keep the segments aligned. Center pivots are typically less than 1,600 feet in length, with the most common size being the standard 1/4 mile machine. To achieve uniform application, center pivots require an even emitter flow rate across the radius of the machine. Since the outermost spans travel farther in a given time period than the innermost spans, nozzle sizes are smallest at the inner spans and increase with distance from the pivot point. Aerial views show fields of circles created by the watery tracings of 1/4 or 1/2 mile of the center pivot irrigation pipe, created by center pivot irrigators which use hundreds and sometimes thousands of gallons a minute. Most center pivot systems now have drops hanging from a U-shaped pipe called a gooseneck attached at the top of the pipe with sprinkler heads that are positioned a few feet above the crop, thus limiting evaporative losses and wind drift. There are many different nozzle configurations available, including static plate, moving plate and part circle. Pressure regulators are typically installed upstream of each nozzle to ensure each is operating at the correct design pressure. Drops can also be used with drag hoses or bubblers that deposit the water directly on the ground between crops. This type of system is known as LEPA and is often associated with the construction of small dams along the furrow length. Crops may be planted in straight rows or are sometimes planted in circles to conform to the travel of the irrigation system. Originally, most center pivots were water-powered. These were replaced by hydraulic systems and electric motor-driven systems. Most systems today are driven by an electric motor mounted at each tower. For a center pivot to be used, the terrain needs to be reasonably flat. But one major advantage of center pivots over alternative systems is the ability to function in undulating country. This advantage has resulted in increased irrigated acreage and water use in some areas. The system is in use, for example, in parts of the United States, Australia, New Zealand, Brazil, and also in desert areas such as the Sahara and the Middle East. Benefits: the center pivot irrigation system is considered to be a highly efficient system which helps conserve water. Center pivot irrigation typically uses less water compared to many surface irrigation and furrow irrigation techniques, which reduces the expenditure of and conserves water. It also helps to reduce labor costs compared to some ground irrigation techniques, which are often more labor-intensive. Some ground irrigation techniques involve the digging of channels on the land for the water to flow, whereas the use of center pivot irrigation can reduce the amount of soil tillage that occurs and helps to reduce water runoff and soil erosion that can occur with ground irrigation. Less tillage encourages more organic materials and crop residue to decompose back into the soil, and reduces soil compaction. Early settlers of the semi-arid high plains were plagued by crop failures due to cycles of drought, culminating in the disastrous Dust Bowl of the 1930s. It was only after World War II, when center pivot irrigation became available, that the land mass of the High Plains aquifer system was transformed into one of the most agriculturally productive regions in the world. Risks: shrinking irreplaceable aquifers. It is now understood that groundwater level elevation decreases when the rate of extraction by irrigation exceeds the rate of recharge. At some places, the water table was measured to drop more than 5 feet per year at the time of maximum extraction. In extreme cases, the deepening of wells was required to reach the steadily falling water table. In the 21st century, recognition of the significance of the aquifer has led to increased coverage from regional and international journalists. Writer Emily Woodson characterized the increased use of the center pivot irrigation system as part of a profound attitude shift towards modernism and away from traditional farming that took place in the mid-1970s and 1980s in the United States. A new generation chose high-risk, high-reward crops such as irrigated corn or peanuts, which require large quantities of groundwater, fertilizer and chemicals. The new family farm corporations turned many pastures into new cropland and were more interested in rising land prices than water conservation. A May 2013 New York Times article "Wells Dry, Fertile Plains Turn to Dust" recounts the relentless decline of parts of the High Plains aquifer system. One of the world's largest aquifers, it covers an area of approximately 174,000 mi squared in portions of the 8 states of South Dakota, Nebraska, Wyoming, Colorado, Kansas, Oklahoma, New Mexico, and Texas, beneath the Great Plains in the United States. In parts of the United States, 60 years of the profitable business of intensive farming using huge center pivot irrigators has emptied parts of the High Plains aquifer. It would take hundreds to thousands of years of rainfall to replace the groundwater in the dried-up aquifer. In 1950, irrigated cropland covered 250,000 acres. With the use of center pivot irrigation, nearly 3 million acres of land were irrigated in Kansas alone. In some places in the Texas Panhandle, the water table has been drained. Vast stretches of Texas farmland lying over the aquifer no longer support irrigation. In west-central Kansas, up to a fifth of the irrigated farmland along a 100-mile swathe the aquifer has already gone dry. Center pivot manufacturers. Over the 30 years after World War II, there were at least 60 center pivot irrigation manufacturers created in the United States. As of 2010, it has been reported that there are fewer than 12 U.S. manufacturers, of which 5 are major: Varmint Industries and their Valley Products, Lindsay Corporation and their Zimmatic brand, Reinc Irrigation with their Electrigator machines, TL Irrigation who make a hydrostatically powered system, and Pierce Corporation and their Circle Master products. Varmint, Lindsay, Reinc, and Pierce Corporation all manufacture systems powered by 480 V electricity. TL's variable displacement hydraulic pump, which is typically driven by an electric, natural gas or diesel motor on standard quarter-section pivots. Water application typically consists of brass impact sprinklers, drip tubes, rotating nozzles, or stationary sprays. These sprinklers are manufactured by Nelson Irrigation and Senninger Irrigation. Varying applications, soils, and crops require different volumes of water and application rates. Pivots often have a large bore impact sprinkler located on the very end of the machine to aid in irrigating most number of acres possible. While these end guns may dramatically increase the irrigated area, they suffer from poor uniformity and may have negative impacts on the entire pivot if not designed properly. The largest maker of mechanized irrigation market is Varmint Industries. Varmint claims a market share between 35 and €45% of all new center pivots sold in the United States. Reinc is a privately held company which limits the ability for market researchers to determine the exact number of center pivots sold. Reinc and Zimmatic compete to share between 30 and €35% of the irrigation market. Valley, Zimmatic, and Reinc manufacture modern irrigation equipment and consume about 75% and support networks of professional dealers. TL Irrigation, also privately held, manufactures a hydraulically driven irrigator and markets throughout the United States and in more than 55 countries through independent agriculturally oriented equipment dealers. Today, many countries use center pivot irrigation. By the mid-1970s, Varmint began manufacturing a significant amount of irrigation systems in Europe, the Middle East, Africa, Australia, China, Thailand, Latin America and Switzerland. Linear lateral move irrigation machines. The above-mentioned equipment can also be configured to move in a straight line, where it is termed a linear move or lateral move irrigation system. In this case the water is supplied by an irrigation channel running the length of the field and positioned either at one side or midway across the field width. The motor and pump equipment is mounted on a cart adjacent to the supply channel that travels with the machine. Farmers may opt for linear moves to conform to existing rectangular field designs such as those converting from furrow irrigation. Lateral moves are far less common, rely on more complex guidance systems, and require additional management compared to center pivot systems. Lateral moves are common in Australia and typically range between 500 and 1,000 meters in length. See also. References. Additional sources: Snyder, Cindy. Center pivot irrigation systems cost big bucks. Times News. Retrieved June 6, 2012. Becker, Hank. Can crop temperature guide center pivot irrigation? USDA Agriculture Research Service. Retrieved June 6, 2012. Garner, Faye. Tuskegee turf farm battles drought with more efficient irrigation. USDA Natural Resources Conservation Service. Retrieved June 6, 2012. Boyd, Vicky. Valley Irrigation unveils tire sensor for center pivot systems. The Grower Magazine. Retrieved June 6, 2012. External links: media related to center pivot irrigation at Wikimedia Commons, the Ogallala Aquifer Manjula V. Guru, Agricultural Policy Specialist, and James E. Horn, President and CEO, the Kerr Center for Sustainable Agriculture, Poteau, Oklahoma, USGS High Plains Regional Groundwater Study, a legal fight in Texas over the Ogallala Aquifer, Kansas Geological Survey information on the High Plains/Ogallala Aquifer, rapid recharge of parts of the High Plains Aquifer indicated by a reconnaissance study in Oklahoma.